Hi everyone. Today we'd like to start one new concept that it is nothing but facts controllers. It is very much helpful for the research and also it is very much helpful for the final year students of electrical and electronics engineering. That it is, I'd like to start our session here. Facts controllers. These are the contents we have to cover in today's class. Facts concept, power flow, loading capabilities, and dynamic stability considerations, importance of controllable parameters, basic types of facts controllers, benefits. These are the contents we have to cover. Yeah. What is meant by facts? Facts is nothing but flexible alternating current transmission systems. What is the definition for facts? It's an AC transmission system incorporating the power electronic based controllers in order to enhance the controllability and also increase the power transfer capability. This one is a basic definition for FACTS. Power electronic based controllers to enhance controllability and it can increase the power transfer capability. And what is meant by FACTS controllers? It's a power electronic based system and other equipment that provide control of one or more AC transmission parameters. This one is also known as FACTS controllers definition. Next, try to know what is the need for transmission interconnections. The main purpose of transmission interconnections is nothing but, apart from power delivery, in order to pool power plants and load centers, we have to have some minimize the total power generation and fuel cost. Our main intention is I would like to minimize power generation and fuel cost, our intention wise. While going for these transmission interconnections, we are also having some other advantage. We can have some minimum cost with a required reliability. What is meant by reliability? Reliability is nothing but it's a combination of dependability and security. Would like to move further. Yeah, try to remember these points while going for the transmission interconnections. Transmission interconnections is nothing but, let it be, so many plants are there. All together plants can be coupled at some one point. That point is nothing but grid. Same parameters. If one of the plant is I don't want to use in some season means I'd like to go for the part of some other option. It can happen only during transmission interconnection only there. And these are the following are the reasons why we go for the transmission interconnections. The main thing is economic point of view. Cost of electricity and it can improve the reliability of power system. First one. Second one, it minimizes the total power generation capacity and fuel cost. And also it has some other advantages, diversity of loads, that it is nothing but they can segregate the things into different categories. Domestic loads, industrial loads, commercial loads, all together that thing is nothing but diversity of loads can happen. Next one, due to interconnected systems, we can have some other option. Maintenance and repairing of old generators is possible with the help of transmission interconnections without disturbing the continuity of supply. Another one, several plants are interconnected now. The reserve capacity of the system is much reduced and results in the overall efficiency of the system improve the things. Finally, due to interconnected systems, we can improve the voltage profile. While if we can improve the voltage profile, the quality of the power also improves. These are the main points for the part of which thing interconnections, transmission interconnections. Next one. What is meant by power flow in an AC system? Power flow in an AC system is nothing but this entire all these diagrams is nothing but it's a measured system. Out and out we can follow measured system. Actually we can have some parallel paths also there. Power flow in parallel paths. But power flow in parallel paths can have something is nothing but we can follow one formula that it is nothing but P equal to EV by X sin delta. If there is any reduction in the reactance, there is some improvement in the part of active power that it can follow in parallel paths. While coming to the part of measured systems, let it be A, B, C. 3 generators and load centers, all these things will be there. Yeah, if there occurs any one of the generating system is failed means the other one will compensate that thing. That one is the main advantage for the part of which thing measured system. Out and out we can follow measured system only there. In that particular lines, if there is any drop in the voltage means I would like to stabilize that voltage with the help of capacitors. by the compensating that one. And also we can use some variable generation parts angle also there. This indicates variable phase angle regulator. This one is nothing but variable capacitor. This one is nothing but variable inductor. All these things are nothing but some compensating devices. If there occurs any drop in the voltage, drop in the part of so many power quality issues will be arised. In order to nullify those all these things, we plan to follow these compensating devices: capacitor, inductor, phase angle regulator. Yeah, we'd like to learn deep into the things in the further session. Next. Yeah, what limits the loading capability? Try to understand the meaning. Loading capability in the sense, if I'd like to actually for a particular thing, I'd like to have some 10 megawatts of load, means beyond that thing also I'd like to use. At that time, we can have some so many limitations will be there. Those are the things of three main points: thermal, dielectric, stability. What is meant by thermal? Thermal in the sense, it's directly related to the function of temperature, ambient temperature, and it can have some impact on the part of wind conditions, conditions of conductor, and ground clearance also there. In order to nullify this entire part of thermal limitation, I would like to use FACS technology. Can help in making an effective use for the newfound line capability. I would like to use the effective utilization of the entire line only with the help of FACS technology. Same thing. The another limitation here is dielectric. Dielectric in the sense, it's an let it be capacitor, in the sense separation of two parallel plates will be there. In between the things we can use some dielectric material. Yeah, there are designed these lines. When I would like to use some, if there occurs any loading capability, means it can increases the voltage level some situation by 10% or even higher. But it can cause some power quality issue. In order to make that entire voltage to the normal levels, I would like to use same criteria, FACS technology. Yeah, dielectric can increase the operation voltage by how much? 10% or even higher. Care should be noted to ensure the dynamic and transient over voltages. These are old over voltages now. I would like to make it into within the limits. For that sake, I would like to go for the part of FACS technology. Same criteria. Next, stability. Coming to the stability point of view, the stability issues that limit the transmission capability include which type of stability? Transient stability, dynamic stability, steady state stability. Depends upon the things of three types of stability issues we can arise: voltage collapse, subsynchronous resonance problems also there. All these are problems, limitations. In order to nullify all these limitations, I would like to go for the part of which technology? FACS technology. FACS technology can certainly be used to overcome any of the stability limits. These are the three main points for the part of which thing? Loading capability limits. Don't forget, thermal directly related to temperature. Dielectric is it increases the voltage by 10% or even higher. Stability also, it can causes voltage collapse and subsynchronous resonance. Altogether, I'd like to have some alternative. That one is nothing but FACS technology. Next. Yeah. The next one here. Power flow and dynamic stability considerations of a transmission interconnection. I know what is meant by transmission interconnection right now, but I'd like to go for the part of dynamic stability considerations. Yeah. Just one diagram is there now. It's a simple two mesh system. It's a simple two mesh system. One bus, second bus. In between the thing, reactance will be there X. And the current carrying some across the part here is I. Voltage across this one is V1 at an angle delta 1. This here V2 at an angle delta 2. And the driving voltage here is VL. This one is a simple two mesh system. Yeah. Let it be that V1 leads V2 by an angle of delta will be there. Let it be. V1 leads V2 by an angle of delta. And VL is nothing but driving voltage perpendicular to the path of current. Yeah, just remember this diagram. I'd like to use this basic thing. V1 leads V2 by an angle of delta. And what is the dynamic stability considerations is nothing but, let it be, I'd like to change the delta, means what are the required power flow conditions. Yeah, power flow, active power flow and reactive power flow. Is there any impact on the varying of delta? That it is nothing but dynamic stability considerations. V1 is the sending end voltage, V2 is the receiving end voltage. X is nothing but impedance or reactance. Yeah, I'd like to neglect capacitance here. Let it be. If I'd like to plot one phasor diagram, maybe like this. What's this phasor diagram is nothing but, remember the basic line. Take it V2, V1 leads V2 by an angle of how much? Delta, load angle. Yeah, just observe this. It's not a complicated issue, but try to observe clearly. We can easily understand this part. Our intention is, what is the impact of active and reactive powers if there is any variation in the delta angle. Just I have only V1, V2 at an angle of delta. Yeah, observe. Drop a perpendicular onto the x-axis from this point here. We can have some, this one is V1 na, and drop a perpendicular on this part means this one is adjacent. And the angle here is V1 cos delta. Adjacent side na. Opposite side is nothing but angle opposite V1 sin delta. This one is a triangle. Next one. Same thing. Drop a perpendicular from point V2 onto this axis. This axis. This one is nothing but adjacent na. This one for this triangle adjacent. V2 cos delta. Opposite is nothing but V2 sin delta. Yeah, just observe. Just I'd like to drop one perpendicular onto the x-axis. From this point also I'd like to drop one perpendicular onto the x-axis. We can have some components V2 cos delta, V1 cos delta, and sine components also there. But moving further, this entire part is nothing but V1, and up to this point is nothing but V2 cos delta. What's a small portion is nothing but subtract from this point this entire area, that it is V1 minus V2 cos delta is the remaining portion of this one. And moving to this point, same thing. Total voltage here is V2, and for this point, this one is V1 cos delta. What's this remaining portion is nothing but V2 minus V1 cos delta. Yeah, I hope you understand. Yeah, moving on to the next criteria. This one is V1 sin delta, na? Same thing, V1 sin delta. We can have some current components right now. Current components we can have, this one is V1, and in phase with the part of this V1 we can have some IP1. IP stands for active current component. In some of the textbooks they may written as D also there. Direct axis components, quadrature axis components is also there. Same thing. In phase to the part of V2 we can have some IP2. Remember that thing. IP2 in phase. Yeah. Perpendicular to the part of this current we can have some other quadrature current, that it is reactive current component. Yeah, this one is IP2 na. Perpendicular to the IP2 we can have some IQ2. Perpendicular to the part of IP1 we can have some this one IQ1. Yeah, that's a final issue. IQ1 is nothing but we all know V equal to IR na. From that what is the I value? V by R. In terms of R we can have some only reactance X. That's why IQ1 is nothing but this entire small portion divided by X. Small portion is nothing but V2 minus V1 cos delta by X is the value of IQ1. Same thing. IQ2 is nothing but, yeah, move on to this particular line, this one. This small portion divided by X is the value of which thing? IQ2. IQ2 is nothing but here, this one. This small portion divided by X. IQ1 is nothing but here, this one. V1 minus V2 cos delta by X is the value of IQ1. Yeah. What is the value of IP1 is nothing but V2 sin delta by X. V by X is the formula for current. This one is active current component of first bus. IP2 is nothing but V1 sin delta by X is the value of IP2. Yeah. I evolved so many parameters right now here. These are the components. Next slide. The active and reactive components of the current is nothing but IP1 is also equal to ID1 also there. No problem. In some of the textbooks ID1 is also given, that it is nothing but active current components or else direct axis current component. Yeah. Remember we have some formula P equal to V1 V2 by X into sin delta. V1 is nothing but sending end, receiving end, reactance. From this particular thing, what is the value of P1 is nothing but V1 into IP1. This entire IP1 value is nothing but this one. Remember, IP1 is nothing but or ID1. V2 sin delta by X1 is the value na, that it is. Q1 is equal to V1 IQ1. Reactive na, IQ1 is nothing but this entire value. IQ1. I know this IQ1 is nothing but the small portion divided by X. Same. Similarly, the active and reactive components of the current flow at bus 2, IP2 or ID2, same V1 sine delta by x1, this one, that it is P2 is equal to V1 V2 sine delta by x1. From this, what's the value? V2 into IP2 is the value, V2 into IP2. What's the remaining value? V1 sine delta by x1 is the value of which thing? ID2. That's the only thing they have written. Q2, same portion. V2 into IQ2 is the value of reactive power. Observe this from particular equations. P1 value and P2 value, is there any variation? No, these two are same. Active power doesn't change when I would like to change the values of delta. Same. Reactive power components are different. Observe this particular thing. In dynamic stability considerations, reactive powers are different, active powers are same at buses 1 and 2. This one is the final conclusion for this one is for dynamic stability considerations. Next one. Observe this frequent diagram in power systems. This one is diagram for active power to the part of angle. Active power to the part of angle. When I would like to plot one diagram maybe like this, you can have some exponential rising up to the point and decaying. The maximum value here is up to 90 degrees. The active power is maximum. Beyond the 90 degrees, it's decaying the part. This one is nothing but power angle characteristics. We all know increase and decrease of x will get increase and decrease of the height of the curves respectively. And don't forget this formula, active power V1 V2 by x into sine delta. With the help of this one only we can have so many conclusions will be there. This one is a question for dynamic stability considerations. Next one, controllable parameters. What are the controllable parameters? Is nothing but we are having some control of line impedance, control of angle, series voltage injection, parallel voltage injection. For the part of control of line impedance, we can have some control on two parameters, current and active power. Same thing, control of angle also, current and active power control. Coming to the part of voltage injection in parallel or series, we can have some current, both active and reactive power control is also possible. These are the controllable parameters. Remember, Z, delta, voltage injection in series and parallel. But to the part of impedance and angle, I don't want to have some parameter on the part of reactive power. We can have only some impact on current and active power. Whereas in this particular voltage injection, we can have some impact on all the parameters, current, active and reactive power control. Yeah, controllable parameters with facts. Yeah, that's outlined here. Increase or decrease of x, active power can be controlled. In the previous diagram, we observed that thing. Increase or decrease of x, I can increase up to the level of delta equal to 90 and thereafter it can reduce. That it is active power. Na? Control of phase angle, which controls which thing? Current flow and active power flow. If phase angle is not large. For the sake of injection of series voltage, we can have some, and in the quadrature perpendicular to the part of current, this can increase or control active power, decrease the magnitude of which thing? Line current. Inject voltage in series with the line with any phase angle with respect to the driving voltage. Previous one, it's a quadrature. If it is any phase angle means it can control both active and reactive power. That one is one more conclusion. Next line, inject a voltage in phase with the sending or receiving end voltage. Is nothing but it can alter the magnitude of which thing? Terminal voltage. We can use any combination. Just remember this slide. There we can understand the entire parameters. Yeah, these are the controllable parameters with facts. Quadrature in the sense I can control only active power. With any phase angle means I can control both active and reactive power. Yeah. Inject a voltage in phase with the sending and receiving end voltage means I can alter the magnitude of terminal voltage. Next, basic types of fax controllers. We'd like to move on to the next criteria. Types of fax controllers. Series controllers, shunt controllers, combined series and series controllers, combined series, shunt controllers. These are the categories. Series controllers is nothing but just remember only one thing. Let it be this one is transmission line. This one is a power electronic based switch. That it is thyristor symbol maybe like this. Let it drawn like this. E is nothing but EMF or voltage. Series controllers, it could be a variable impedance or power electronic based variable source of main frequencies, subsynchronous and harmonic frequencies to serve the desired need. Yeah, these are the lines we have to remember. Series in the sense, in series connection, current is same now. I don't want to disturb that one. I would like to go for the some other voltage. That it is in series, inject a voltage in series with the line. If the voltage is in phase with the phase quadrature with the current, controller supplies or consumes which thing? Reactive power. Voltage is in phase quadrature with the which parameter? Current. Any other phase involves control of both active and reactive power. In the previous slide, quadrature in the sense I would like to supply or consumes reactive power. Any other phase means I would like to control both active and reactive. Remember that line. But basic line is series in the sense injects voltage in series with the line. These are the diagrams. Yeah, transmission line. We bother about only this transmission. Our subject itself indicates facts in the sense flexible alternating current transmission system. This one is transmission line. This one is series transformer coupled to the part of this one. This one is nothing but VSC, voltage source converter, and a capacitor. Same this one. This one, all these are series connected controllers only there. Series connected controllers. The first diagram is nothing but triple SC. This one is nothing but some storage triple SC. Triple SC stands for static synchronous series compensator. Triple SC stands for static synchronous series compensator. This diagram is for the part of in series. I'd like to use one capacitor. That's why the name for this particular one is TCSC, thyristor controlled series capacitor. This one is nothing but TS TCSR. This one is reactor na, that's why thyristor controlled series reactor. Remember that thing. Or else we may call it as TSSR is also same. All these are different types of series connected controllers. In the line itself, series only I'd like to connect. That's why these names are series connected controllers. It injects a voltage in the line. Next one, shunt controllers. This one is shunt, parallel. I would like to have some parallel. In the previous slide, observe this one. Series in the sense I would like to inject which thing? Voltage. In shunt in the sense I would like to inject which thing? Current. Observe that parameter. Don't try to draw this one. One box that it is VSC. Some transmission line parallel. Inject a current in the system. If the current is in phase quadrature, yeah, whatever the line we are writing here, that one is the main thing. That one is the reference. If the current is in phase quadrature with the voltage, controller supplies or consumes which parameter? Reactive power. Any other phase involves control of both active and reactive power. Shunt in the sense inject current. Don't forget that thing. And don't forget to write this diagram also. In shunt, these are the different controllers. We would like to learn deep into the things in the further sessions. Don't bother about the part. Shunt main criteria here is it inject current into the line. That it is transformer is connected in parallel. This one is a transformer symbol. This one is a voltage source converter. That it is anti-parallel of thyristor in combination to diode and storage device capacitor, inductor, storage part. If I'd like to use only reactor means that it is thyristor switched reactor. TSR stands for thyristor switched reactor. TCR stands for thyristor controlled reactor. If I'd like to place capacitor here means thyristor switched capacitor. Yeah, just LC means it's a filter. These are the different categories. This diagram is for the part of STATCOM. STATCOM full form static synchronous compensator. Static synchronous compensator is an example of shunt connected controller. Next one, combination of both the things. Combined series. I'd like to use combined series. This one is one line series. Next one is series. Try to connect it with the help of DC power link. That it is series in the sense injects voltage. Na? That's only parameter. And this particular name here is combined series particular name. That name is IPFC. Interline power flow controller is nothing but IPFC. It's an example of combined series controller. In the competitive exams also they may ask what is the full form for IPFC is nothing but interline power flow controller. Combined series shunt. One thing is shunt, that it is parallel, injects current, another one is nothing but injects voltage series. I'd like to connect it via the part of DC power link. Don't forget this DC power link. It can only manage the active power flow from one point to another point. DC power link advantage. And the example for combined series shunt is nothing but UPFC, Unified Power Flow Controller. Combination of series is nothing but IPFC. Combination of series and shunt is nothing but UPFC. These are the different diagrams. You can observe. First diagram is nothing but ordinary power electron switch fax device. This one is the diagram for which can identify series. This one is the diagram for shunt. And this one is nothing but series IPFC. This one is for the part of UPFC. These are the diagrams you have to remember. All these are different types of fax controllers. Yeah. This one is the diagram, UPFC diagram. One thing is series, another one is shunt. I know shunt is nothing but example STATCOM. Static synchronous compensator. Triple SC. Series in the sense triple SC. Series one transformer, shunt one transformer for this connection. Connection of these two things can happen via the part of DC link capacitor. This diagram is for the part of UPFC. Don't forget this diagram. And the main comparison of UPFC and IPFC is nothing but UPFC capable of controlling real and reactive power flow in the line independently. We can divide independently there. Whereas IPFC, it can equalize both real and reactive power flow between the lines. And as a result, it reduces the burden of overloaded lines by real power transfer. Yeah, these are the differences of UPFC and IPFC. Remember, UPFC we can use frequently here. But the main drawback of this UPFC is it can have only independent operation. IPFC it can balance both the things. But we can use frequently the parts here as UPFC only there. One unit is there for UPFC, there we can learn different things. But till now, remember combined series shunt is a combination of UPFC. This one IPFC is the value of combined series controller. Yeah, finally we learned upon the things of benefits of fax devices. These are the points we have to remember. Yeah, improved power transmission capability. When we need to transmit more power than what the system was originally designed, we need to build a new transmission line. But there is no need to build a new transmission line whenever we go for the fax device. We can use the existing system. That's the main thing. I can use efficiently the power transmission capability. That's the first point. No need to build the new transmission line. Fax device can be the alternate solution for this thing. Next point. Improve availability of power. It has been found that a number of blackouts and power quality issues will be there due to the proper reactive power management. Lack of reactive power management, we can realize so many drawbacks. In order to compensate the drawbacks, I would like to use fax device. That is, it can mitigate the problems. Stability point of view. Fax technology can be used to effectively improve the stability, steady state and transient stability. Remember, transient. We can have some equal area criteria. If A2 is greater than A1 means that it is a transient stability. If the disturbance is small means that it is steady state stability. Next, improve power quality. Yeah, fax devices on the distribution side can be designed to improve power quality. There it can improve the voltage profile. It's an interlink point 4 and 6. Optimal power system operation. Optimal in the sense I can use the system efficiently by reducing the losses. These are the points we have to remember for benefits of fax device. Power transfer capability, availability of power, stability issue, power quality, optimal usage of power system, and voltage profile improvement. These are the points of which saying benefits of fax device. These are the basics for fax controllers till now we discussed. In the further session, we would like to move on to the deep things of what is the STATCOM, what is triple SC, what is UPFC, what is IPFC, all these things we would like to learn further. Thank you very much.